Hello everyone, welcome to my mathematics class, Standard 6, Chapter 6, Playing with Numbers. First we discuss about simplification. To simplify a given expression involving various operations like bracket, of, division, multiplication, addition and subtraction, we use the word for short, that is BODMAS, where B stands for bracket, O stands for of, D stands for division, M stands for addition, A stands for subtraction. Use of bracket. There are four kinds of bracket. One is bar or vinculum, round bracket or small bracket or parenthesis, curly bracket or braces, square brackets or big brackets. This is the bar bracket, parenthesis, braces and square bracket. Let us see how to simplify. Simplify 16 plus 32 divided by 8 minus 2 into 6. 16 plus 32 divided by 8 minus 2 into 6. First performing the operation division. 16 plus 32 divided by 8, 4 minus 2 into 6. Now 16 plus 4 minus performing multiplication, 2 into 6 minus 12. Now performing addition, 16 plus 4, 20 minus 12. Now performing subtraction, 20 minus 12, 8. Example 3. Simplify 14 minus square bracket start, 9 minus curly bracket start, 10 plus 30 divided by small bracket start, 4 minus 8 bar bracket start, 8 minus 6, end of small brackets, curly bracket and square bracket. First, we removing the bar bracket. First to remove the bar bracket, which is the innermost bracket. So 14 minus square bracket start, 9 minus curly bracket start, 10 plus 30 divided by 4 minus, now removing the bar bracket, 8 minus 6, that is 2. So a 4 minus 2 within the small bracket, end up curly bracket and square bracket, is equal to 14 minus square bracket start, 9 minus curly bracket start, 10 plus 30. Now removing small brackets or round brackets, 4 minus 2, 2. So 30 divided by 2, curly bracket end and square bracket ends, is equal to 14 minus square bracket start, 9 minus curly bracket start, 10 plus 15, end of curly bracket, end of square bracket. Now removing the curly bracket, 14 minus 10 plus 15, 25. 14 minus square bracket start, 9 minus 25, end of square bracket. Now removing square bracket, 14 minus 9 minus 25 minus 16. Now minus into minus plus, 14 plus 16, 30. By this way we solve simplifications, and exercise 6a based upon the simplification. Next we discuss about factors and multiples. When a number divides another number exactly, then the divisor is called a factor of the dividend, and the dividend is called a multiple of the divisor. For example, 6. When 6 divides 24 exactly, 6 is the factor of 24 and 24 is a multiple of 6. All factors of 12 are 1, 2, 3, 4, 6 and 12. If we divide 12 by 2, 3, 4, 6 and 12 and 1, the remainder is always 0. So 1, 2, 3, 4, 6 and 12 are the factors of 12. Similarly, factors of 18, 1, 2, 3, 6, 9 and 18. Now multiple of 5, if we multiply 5 by 1, 2, 3, 4, 5, 6 and so on, we get 5, 10, 15, 20, 25 and 30 and so on. So these are the multiples of 5. That indicates, the dots indicates that there are infinite number of multiples of each number. Each number has infinite number of multiples. Now properties of factors. 1 is factor of every number. 1 is the only number having one factor, namely itself. Every number is a factor of itself. For example, 12. 12 is a factor of itself. 18 is a factor of itself. 30 is a factor of itself. So every number is a factor of itself. A factor of a number is less than or equal to the number. The factors of every number should be less than or equal to the number. For example, factors of 12. Factors of 12 are 1, 2, 3, 4, 6 and 12. These 1, 2, 3, 4 and 6 are less than 12 and 12 is equal to 12. So factor of a number is less than or equal to the number. Properties of multiples. Every number is a multiple of 1. For example, 8 is equal to 1 into 8. 9 is equal to 9 into 1 into 9. Every number is a multiple of itself. For example, 6 is equal to 6 into 1. 11 is equal to 11 into 1. Every number has infinitely many multiples as shown above. Every multiple of a number is greater than or equal to the number. Even and odd numbers. Natural numbers which are exactly divisible by 2 are called even numbers. Or in other words, we can say that the multiples of all the multiples of 2 are called even numbers. Every even numbers 0, 2, 4, 6 or 8 as units digit. So 560, 982, 150, 1854, 2746, 10780, 10378, all these are even numbers. The number which contains either 0, 2, 4, 6 or 8 in its unit place are divisible by 2. So these all numbers are even numbers. Odd numbers, natural numbers which are not exactly divisible by 2 are called even numbers. Odd numbers. For example, 1, 3, 5, 7 or 9, etc. Every odd number has 1, 3, 5, 7 or 9 as its unit digit. If the number whose unit place contains 1, 3, 5, 7 or 9 is a odd number. For example, 451, 683, 1075, 1467, 2689 are all odd numbers. Test of divisibility. Divisibility by 2. A number is divisible by 2 if its unit digit is any one of 0, 2, 4 and 4, 6 and 8. For example, 710, its unit digit is 0, so it is divisible by 2. 632, its unit digit is 2, it is also divisible by 2. 854, its unit digit is 4, so it is divisible by 2. So any number which contains 0, 2, 4, 6, 8 and 8 in its unit place is divisible by 2. A number is divisible by 3 only when the sum of its digit is divisible by 3. Consider the number 8,34,051. The sum of the digit 8 plus 3 plus 4 plus 0 plus 5 plus 1 is equal to 27. And the sum of the digit is 27, which is divisible by 3. Hence, 8,34,051 is divisible by 3. Consider another number 6,87,943. Now sum of digits 6 plus 8 plus 7 plus 9 plus 4 plus 3, which is 37, is equal to 37, which is not divisible by 3. 37 is not divisible by 3, so 6,87,943 is not divisible by 3. Divisibility by 4. A number is divisible by 4 only when the numbers formed by the last two digits, that is the tens and unit ones digit, is divisible by 4. A number is divisible by 4 only when the number formed by the tens and units digit is divisible by 4. For example, consider the number 6,70,032. The unit and 10 plus digits are 3 and 2. The unit plus and 10 plus digits form the number 32. 32 is divisible by 4. So 6,75,032 is divisible by 4. Consider the number 8,26,134. Its last two digits means the units and tens plus digits form the number 34, which is not divisible by 4. 34 is not divisible by 4. 34 is not a multiple of 4. So 8,26,134 is not divisible by 4. Divisibility by 5. A number is divisible by 5 only when its unit digit is either 0 or 5. For example, 8,720. Its unit digit is 0, so it is divisible by 5. 93,125. Its unit digit is 5, so it is divisible by 5. So any number which contains either 0 or 5 in its unit place is divisible by 5. A number is divisible by 6 only when it is divisible by both 2 and 3. Very important. A number is divisible by 6 only when it is divisible by both 2 and 3. Then the number will divisible by 6. For example, consider the number 78,162. Its unit digit is 2, so it is divisible by 2. Now sum of the digit 7 plus 8 plus 1 plus 6 plus 2 is 24. 24 is also divisible by 3. So 70,162 is divisible by 6. Consider the number 93,206. Its unit digit is 6. It is divisible by 2. Now sum of the digit 9 plus 3 plus 2 plus 0 plus 6 is 20, which is not divisible by 2. So the given number is not divisible by 3. The number is divisible by 2 but not divisible by 3. So it is not divisible by 6. So the number 93,206 is not divisible by 6. Divisibility by 7. A number is divisible by 7 if the difference between the double digit at one's place and the number formed by the rest of the digit is divisible by 7. Consider the number 6,895. Now 6,006 now double the digit of one's place. 689 minus 2 into 5 is, which is equal to 689 minus 10, that is 679. 679 is divisible by 7. So 6,895 is divisible by 7. Another example, 88,165. Now double the unit digit remaining. Now 816 minus double the unit digit 2 into 5. 816 minus 10, that is 806, which is not divisible by 7. So 8,165 is not divisible by 7. Divisibility by 8. A number is divisible by 8 only when the number formed by its last 3 digits on its extreme right is divisible by 8. That is, the number formed by the digits at ones place, tens place and hundreds place. Consider the number 66,75,000. 67,54,112. The number formed by its last 3 digits, that is 1 plus, 10 plus and 100 plus, is 112, which is divisible by 8. 112 is divisible by 8. So 67,54,112 is divisible by 8. Divisibility by 9. A number is divisible by 9 only when the sum of the digits is divisible by 9. Consider the number 87,102. Now sum of the digit 8 plus 7 plus 1 plus 0 plus 2 is equal to 8. This 18 is divisible by 9. So the number 87,102 is divisible by 9. Divisibility by 10. A number is divisible by 10 only when its unit digit is 0. If the unit plus digit of a number is 0, then the number is divisible by 10. Consider the number 2,78,590. Its unit plus digit is 0, so it is divisible by 10. Divisibility by 11. A number is divisible by 11 if the difference between the sum of the digits at odd places and the sum of the digits at even places from extreme right is either 0 or a multiple of 11. Consider the number 75,438. Now sum of digits at odd places from the right. 8 digits 847, that is 19. Now sum of digits at even places, 3 plus 5 is equal to 8. So 19 minus 8, the difference is that 19 minus 8 is equal to 11, which is divisible by 11. So 75,438 is divisible by 11. Now prime and composite number. Prime numbers, the natural numbers having exactly two different factors, namely 1 and the number itself, are known as prime numbers. For example, 2, 3, 5, 7, 11, 17, 19, 13, 23. These are the prime numbers because they have only two factors, 1 and the number itself. Composite number, a natural number which has more than two factors is called composite number. For example, 4, 6, 8, 9, 10, 12, 14, 15, 16 are composite number. They have more than two factors. 1 is neither prime nor composite. 2 is the only even prime number. Remember these points. To find all prime numbers between 1 and 100. Eratosthenes, a Greek mathematician, devised a simple method for finding all prime numbers between 1 and 100. The tabular arrangement of prime numbers obtained below is known as Sieve of Eratosthenes. Method 1. Write down the numbers from 1 to 100. Here, first write down the numbers from 1 to 100. We know that 1 is neither prime nor composite, so cross out 1. Now encircle 2 and cross out the remaining multiples of 2. Now cross out the multiples of 2, that is 2, 4, multiple of 2 are 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50, 52, 54, 56, 57, 58, 60, 62, 64, 60, 66, 68, 70, 72, 74, 76, 78, 90, 82, 84, 86, 87, 88, 86, 88, 90, 92, 94, 96, 98, 100. Now encircle and cross out the remaining multiples of 3. Now encircle 3 and cross out the remaining multiples of 3 as 6, 9, 12, 15, 18, etc. and etc. Now encircle 5 and cross out the remaining multiples of 5. Now 5, the multiples of 5 are 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. Encircle 7 and cross out remaining multiples of 7. Encircle 7 and remaining multiples of 7 are 14, 21, 28, like that. Now encircle each of the remaining numbers. Now encircle the remaining numbers. This is the method of sieve of Eratosthenes. All encircle numbers are prime numbers. There are 25 prime numbers between 1 and 100. How many prime numbers are there? 25 prime numbers between 1 and 100. All the prime numbers between 1 and 100 are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89 and 97. Each crossed number except 1 is a composite number. Each crossed number except 1 is a composite number. Now, twin primes, pair of prime numbers which differ by 2 are called twin primes. Pair of twin primes between 1 and 100 are 3, 5, 5, 7, 11, 13, 17, 19, 29, 31, 43, 143, 51, 6, 59, 61, 71, 73. You see the difference between these two prime numbers is 2. So they are called twin prime numbers. Prime factors. All the factors of a number which are prime numbers are called the prime factors of the number. For example, all prime factors of 12 are 2 and 3. Factors of 12 are 1, 2, 3, 4, 6 and 12. But out of all these factors, the prime factors are 2 and 3. Similarly, prime factors of 35 are 5 and 7. Co-prime number. Two natural numbers which do not have a common prime factor are called co-prime numbers. Two natural numbers which don't have common prime factor are called co-prime. For example, 2, 3, 3, 4, 4, 1, 11, 13, 16, 25 are all pair of co-primes which two natural numbers which don't have a common prime factor are called co-prime. Prime factorization, the process of writing composite number as the product of prime factors, is called the prime factorization of the given number. Methods of prime factorization of a given number. Divide the given number by the smallest prime factor of the given number. Go in dividing each of the subsequent quotient by the smallest prime factor till the last quotient is 1. Express the given number as the product of all these factors. Is 21 a factor of 627? First divide 627 by 21. On dividing, we get 32 as quotient and 0 as remainder. So, since 0 is the remainder, it means that 672 is exactly divisible by 21. Hence, 21 is a factor of 672. Write all possible factors of 96. We have 96 is equal to 1 into 96, 2 into 48, 3 into 32, 4 into 24, 6 into 16, 8 into 12. So all possible factors of 96 are 1, 2, 3, 4, 6, 8, 12, 16, 24, 32, 48, 96. Express 462 as product of primes. First, by successive division of a given number prime factors, we get 462 by 2, we get 231. 231 by 3, we get 77. 77 divided by 7, we get 11. 11 divided by 11, 1. So 462 is equal to 2 into 7 into 3 into 7 into 11. And exercise 6b based upon these things. In the next video lecture, we will discuss about highest common factor or greatest common factor, HCF or GCD. I have tried my best to make you understand the concept, and I hope you understand very well. Thank you.